All right, Algebra 2. This is Unit 1-1. We're going to be looking at functions. And a lot of this, I guess, Unit 1 is going to be review. A lot of the stuff you're going to have seen from Algebra 1, I believe. All right, so looking at a function. So a function is a relationship between the input values and the output values. So input are the x values and the output are the y values. All right, so you can kind of think of, let's say, an XY table. Okay, so if we had an XY table, it's going to look like something like that. And all these values that are on the x side are the input values. And then all the values that are on the right side, or under the y's, those are the output values. Now, the domain of any function or non-function, doesn't even have to be a function, are all the x values. Okay, so we list all the x values. Sometimes we're going to list specific values, sometimes we're going to use inequality, sometimes we're going to use interval notation. And then the range are all the y values that make up the function. Now, if it's a function, what we're looking for are the x values. Okay, and the x values are not allowed to repeat. And we have a specific test that we can look at. If we have a graph, we can do what's called the vertical line test. Okay, and we'll talk about that later. But if you have just ordered pairs or an XY table and you're trying to decide if it's a function or not, you're just going to look at the x values, and if the x values don't repeat, then it's a function. And if the x values do repeat anywhere, then if it repeats, it's not a function. Okay? The y values can repeat as many times as they want. So you might see repeating y values or not, but it has nothing to do with if the expression or the relationship is a function or not. All right, so notation. We're going to be writing answers in a couple different notations to start off. So we're going to be looking at inequality notation and interval notation. All right, and so we use notation to describe all the values that make up a set. So we can talk about the x values, which typically we would talk about the domain for the x values, or the y values, and that would be the range values. We can be given a table to do this, a set of ordered pairs, a graph, or what's called a mapping. All right, and I'll give you examples of each of those a little bit later on in the lesson. All right, so the two different kinds of notation that we're going to be looking at is inequality and interval. So inequality and interval, when we're talking about specific numbers, we're going to use braces to list out each of the numbers that make up the set or the solutions to a set. And we separate them by commas. And typically you'll order from smallest to biggest. Now, if we have any inequality symbols, then we use inequalities. If we can't list all the solutions out with specific numbers, we have to use like a range of values. And so we're trying to describe all the numbers. And so sometimes it's not easy to do that with just specific numbers, and you have to use inequalities because there could be fractions or decimals involved, and so inequalities are going to be easier to describe the solutions to some set. All right, interval notation. We use that also. It's just a different way of writing the solutions. And we use the endpoints along with parentheses or brackets to describe it. Parentheses are going to be used if we want to indicate a value that's not included. So it's an endpoint, but it's not included in the solution. And then we use brackets to indicate that the value is included. And then infinity and negative infinity will also be used in interval notation. On a graph, if you see an open circle on a graph, that means that number is not included in the solution. And if you see a closed circle, that means that value is included. All right, so here's a couple graphs. And so we're going to practice writing the solutions that are shaded in inequality notation and interval notation. All right, so in inequality notation, we can see we have one endpoint and then it's shading off to the right. So that means everything that's being shaded is everything that to the right of 5 or greater than 5. So to write this in inequality notation, we can write x is greater than or equal to. Okay, so we want to put the equal to sign symbol under it, and then 5. Right, so x is greater than or equal to 5. So I typically, when I'm doing inequality notation, I always put the variable first, x, and then I put the inequality in, greater than or equal to, less than or equal to, and then I put the number in. Okay. When you put the inequality in, the direction that you see the point of your inequality should be the same as its shading. So if it's shading to the right, it should be pointing to the right for your inequality. All right, and then let's do the inequality for the second graph. So this says everything between -3 and 7 are being shaded. So that's greater than -3, but less than 7. So when you write this, what we're going to do is put -3. So anytime you have shading in between two numbers, you're going to start it out. The first number that's on the left side is -3 here, and then +7 is last. All right, so you're going to leave a space, because we're going to put an inequality in there, x, that represents all the shading, and then leave a space, and then 7. All right, so you can see -3 is on the left, 7 is on the right, and so we want to indicate that everything's being shaded, all the solutions lie between -3 and 7. Now the inequalities that you put in, they're always going to face to the left or less, right? Now, because -3 has an open circle, that means -3 is not included. So we're going to just leave it without the equal sign, right? And then 7 does have a closed circle, so it is included in the solution. So we're going to put the less than with an equal sign, right? So the way you read this is x is greater than -3, but less than or equal to 7, right? And so this is a shorthand way of writing that. So again, anytime you see shading in between, this is the model kind of that you want to use. So the first number is on the left, and the second number is on the right, x in the middle. Both inequalities will always face to the left, though. All right, now in interval notation, we use the endpoints. All right, and you're always going to think working from left to right. All right, so it's always left to right. So as we move on this graph from 5 to the right, 5 comes first. So what we're going to do is do a bracket on 5. Now we use a bracket because the 5 has a closed circle. All right, now as we move to the right, we can see everything's being shaded, and it's all being shaded all the way over to positive infinity. That means everything's being shaded that's greater than or equal to 5. All right, so then we do a comma and then positive infinity. And with infinity, we always use parentheses, so never use a bracket, because you can't actually include infinity. It's not an actual number. All right, and then let's do the second one from -3 to 7. So as we move from left to right, again, for interval notation, -3 is going to come first. All right, and then we're going to use a parentheses on the -3 because it's an open circle, it's not included, and then comma, and then +7. Now 7 is closed, so we use a bracket because 7 is included. So this has all the solutions between -3 and 7. So that's all the fractions, decimals, every number between -3 and 7. -3 is not included, but 7 is. All right, so given interval notation, we're going to graph it and write the inequality notation. Okay. So this says everything should be shaded between +2 and 5. All right, so you just have to really just put those numbers that they give you. You don't have to put a whole bunch of numbers on the number line. So 2 is coming first. All right, so we're going to do an open circle on 2. And then 5 would be to the right. All right, and it's going to be a closed circle on 5. And then we're going to shade everything in between +2 and 5. All right, so that's everything between 2 and 5. So now when we write the inequality, okay, it's similar to the one that we did above. All right, so 2 comes first, then x, and then 5. Both inequalities face left. So the 2 is just going to have a less than because there's the 2 is not included. It's an open circle. and then 5 is included, so less than or equal to. All right, the second one, negative infinity to 5. All right, so again, think of working left to right. So negative infinity is on the leftmost part that you can go. All right, so everything's being shaded from negative infinity all the way to the right, which would be positive 5. Again, we're going to have a closed circle on 5. So when we shade this, red here. Okay, so this is everything to the left of 5, or less than 5. And so when we write this, okay, as an inequality, again, with inequalities, I think it helps to just put the x first, the variable, and then the direction that you're shading, we're shading to the left, so our point should be to the left, and it's going to be less than or equal to, and then 5. So x is less than or equal to 5. All right, the next one, shade everything between 2 and positive infinity. All right, so again, we're working from left to right. So 2 comes first, and this is going to be an open circle at 2, and then shade everything to the right of 2 all the way to where positive infinity would be. All right, so again, positive infinity would be out here. All right, we're shading everything that's greater than 2. So the inequality would be x is greater than 2. All right, again, you read that as everything is being shaded that's greater than 2. All right, and this last one, this says shade everything between negative 1 and 1, and then there's a break, and then shade everything between 4 and positive infinity. All right, so this is going to have 2 parts on the shading. So from negative infinity, okay, again, negative infinity is over here, and we're going to shade it all the way to positive 1. All right, so put 1 right here. And that's going to be an open circle. So we're going to shade everything from negative infinity to 1. All right, and then there's going to be a break, and now we're going to pick it up as we move from left to right. Positive 4 is going to have a closed circle. And we're going to shade everything to the right of 4 all the way to where positive infinity is. Okay. All right, so when we write an inequality for this one, so you can kind of see there's 2 parts on the shading. This is, for an inequality, this is called an OR problem. And we'll probably get into this when we get to absolute value equations, ANDs and OR problem. But this is an OR problem. All right, so what we're going to do is kind of look at the left one first, that shading. So that says x is less than 1. Then we're going to put the word OR. And then the second shading from 4 to infinity is going to be x is greater than or equal to 4. All right, so x is less than 1 or x is greater than or equal to 4. All right, this next example says determine the domain and range of the following, and then determine if the relation is a function or not. All right, so the domain, again, are the x values of your ordered pairs. All right, so our x values are 6, 3, and 7. And so typically we would write these in order from smallest to biggest. And because these are specific numbers, we're just going to use braces. So just do your best with some kind of squiggly lines when you do this. So our order would be 3, 6, and 7. Okay, 3, 6, and 7. If you have any numbers that repeat in that value, like the x's, only list them one time, so you don't keep repeating the same number. So every number that's listed should only be represented one time instead of duplicates. All right, and then the range are all the y values. Okay, so we got 4, we got 5, and then there's 4 again. All right, so the range, again, order from smallest to biggest, would be 4 and 5. All right, so now the question is this relationship, these ordered pairs, does this form a function or not? And so again, you're only looking at the x values to see if the x's are repeating. And none of the x's are repeating. The y's are, but not the x's. So yes, this is a function. All right, and then this last one, B, the domain, again, are all the x values. And so when they give you an xy table that's horizontally written instead of vertically, when it's horizontal, the x values are on top and the y values are on the bottom. Even if they don't list it out like that, typically that's the way it works. All right, so the domain looks like, let's do a better phrase. All right, so order from smallest to biggest, -2 would come first, then 0, and then 3. And then the range, 5, 6, 7, and 8. All right, and then let's see if this is a function. So again, we're looking at only the x values. Yes, we do have 2 x values here that are the same, and so no, this is not a function. All right, and so that's all we're going to do for this part of Unit 1.1. We're going to finish off the rest of it on the next time we meet.